Yeah, it's going to be super chilly. I'd have to look up the low. It will definitely be below freezing.
It's gonna be negative.
Okay, so it's good to see everybody. So I have just a couple quick little announcements. So last week when I saw you, I only saw you twice because we had the late start day on Thursday. So we've been talking about this right here, the nth root radicals and how to simplify those. So we're going to go ahead and continue to do that today. Uh, we have the homework assignment that I passed out last week. I do have extra copies of it as well as the notes if you need it. But the homework assignment is going to be due on Wednesday, and then we're going to have a quiz over this on Thursday to kind of round out the week. And tomorrow we'll go into exponent rules and we'll start looking at the next lessons. But at the end of today, I want to go ahead and give you an exit ticket. I want to go ahead and give you some problems and have you practice on those. So that'll be for a grade today as well. That's this week. The only other thing I want to mention, give you a heads up, that on Wednesday during 8th period, we have a lockdown drill. So that's the locks, lights, out of sight. That's when all the windows are covered. Did we have any questions if there were a lockdown to occur during 4th? Does everybody know what we would do?
Don't make any stupid. No. Maybe we should play the Squid Game on the hallway, like about when the lockdown.
Okay. But the one thing about the lockdown drills, or even if it's not a drill, we definitely don't want to be in front of the doors. We want to go ahead and be as far away from the windows, basically right around where May is. That's where we want to go ahead and kind of group up. Okay.
Throw a desk in.
Actually, during professional development meetings, we've had conversations as a faculty. If the intruder were to get access to the classroom, what the teacher could use to defend the students. I wouldn't use the students. I wouldn't be all, it's not like in the movies. Okay. No, I said I wouldn't do that. I'll tell you what, that'd be cool. I'll tell you what, though, if they do gain access, I promise you, I don't know what I would do because I'm a middle-aged, overweight guy, but I would do my best to defend you. But like, I would try to go out with a joke. Like, I'd grab a calculator, prepare to be inspired. That is cool, right? And then I'd probably be lying on the ground, but hey, leave them wanting more. Oh, so hopefully, if that were to happen, in all seriousness, if I am dealing with somebody at the door, absolutely try to get out. Because they're already in the room, get out through the other door, just run.
Bring your scissors. Come back here.
We sharpen the end of those flagpoles.
I mean, I've got scissors, I've got blunt objects. I mean, I do have ways that I can defend. I don't know how well that's going to work against a gun, but
So, since we got ourselves a private property, so
What?
we thought of we bought a new house
Huh?
recently, so we are probably like we would buy buy that. We brought it like a lot, like a convenience store or something. Yeah, because it's our like religious thing as a being an Indian.
Okay.
To have a family or something. And also, since we need something for protection, why don't we just get a sword than buying a gun and maintaining it? You have a sword?
so you want to use you use a sword and a firearm as protection?
We only use a sword.
Oh, you only use the sword. Okay. Is a member of your family very fluent with it?
No. It's kind of like ancient thing
Uh-huh.
as Indians, like having their family sword. It's
Okay.
kind of like
So like you get shot, but you're like, I have a sword.
they die with honor.
Okay. This conversation's getting really dark. Okay. So I'm glad that your family has some kind of protection. Okay.
Yeah.
So if you'll go ahead and pull out these notes, and if you need an extra copy, I've got copies right here. Did anybody need one? Okay. Here we go. There we go. Anybody else? Copy of the notes. It'll look like this. It'll say warm up, nth roots right below it. Nobody else? Okay, cool. All right. So the main part of this lesson is being able to simplify radicals, which we've done before, but before we were looking primarily at square roots. Now we're looking to continue simplifying square roots, but also cube roots and fourth roots. That's why you've got these perfect squares, perfect cubes, and perfect fourths here to help you along with that process. Remember, you also have the calculator. If you're looking for a perfect square, cube, or fourth to divide your radicand, you can just divide by what you have here and see which one works out nicely. Okay, so we've already talked about, the parts. Whatever we're trying to simplify is known as the radicand. The index of the root is this tiny number in the top left corner. Okay, remember, it only goes imaginary if it's an even root with a negative radicand. Any other time, we're just going to have the same sign. Okay, and then I believe on Friday, we went ahead and went through a few more of these. So we're just simplifying radicals. In fact, I think we finished that section. And then we started with this section right here. So it was the same idea as far as that value goes, whatever your numerical value inside the radicand is. But we had this new idea if we had a variable. So in order to simplify these, you're going to take the power on the variable and you're going to divide it by the index. Okay. Now, if it divides evenly, that's perfect. That's what we're hoping for. But if it doesn't divide evenly, your remainder is always going to go back inside. Okay, so I think, what was the last one that we did? Was it 12? It was 12? Okay, so let's go ahead and take a look at 13. 13. All right, let me go ahead and move this out of the way. In fact, let me go ahead and I'll erase this. Otherwise, it's all going to kind of run together. Okay, so now I can go ahead and still see those values, but we can also work these other problems here. Okay, now forget about the x to the 10th and the y to the 21st for right now. Simplifying the actual number is just like we've done before. Now, this is a cube root of a negative, so because it's an odd root, this will not be imaginary. Only if it's an even root with a negative number. So what I can tell you right now, remember your answer is always the same sign as your radicand. So I know I'm looking for a negative. Okay. So is 64 a perfect cube? It is. So what number times itself 3 times would give me negative 64? Okay, 4. So it's negative 4. Now, if it were just simply the cube root of negative 64, we'd have negative 4. The problem is over. Okay. But we've got these variables that we want to deal with. So I'm going to put a little bit of distance between this number and my cube root. Remember, I'm going to go ahead and put that in parentheses so that we can tell the difference between a coefficient and my index. Well, let's go ahead and start with x. It's x to the 10th. So I'm going to take that 10 and I'm going to divide it by 3. Well, how many times will 3 divide into 10? 3 times. So that means I can pull out an x cubed. The number of times it divides your power is what you're pulling out. So it goes in there 3, but here's what's important. What's the remainder? Excuse me. The remainder is 1, so I'm just going to leave x to the first inside. Now, we talked about this on Friday. If it's a power of 1, you don't have to put it. But again, just because it's been a couple of days, I'm going to go ahead and do that so we can actually see what's happening. And now let's take a look at y to the 21st. So what is 21 divided by 3? 7. So because it goes in 7, that means I can pull out a y to the 7th, but there's no remainder. So there's no y that stays inside. That's my answer. So the only additional topic that we discussed on Friday was if it's a variable, divide the power by the index. Okay. If there's a remainder, the remainder stays inside as the new power. Okay. All right. Well, let's try another one. The cubed root of a negative 81 p squared q to the 12th. Okay. Now, cubed root of a negative, so just again, just like the previous one, this one will not go imaginary. I know that my answer has to be negative. Is 81 a perfect cube? Okay, so it's not a perfect cube, so that means we have to go ahead and divide it somehow. So because this is a cube root, we're looking at all of these numbers here. What is the largest one that will evenly divide it? 27, yeah. So let's just take a look at the negative 81 on its own. We'll worry about the variables in just a second. If we were just simplifying the cube root of a negative 81, we would say negative 27 times 3. It's not a perfect cube like 13 was, so we're having to break it apart. Okay. Well, what's the cube root of negative 27? Negative 3. Because negative 3 times negative 3 times negative 3 would give me negative 27. Now, this 3 has to stay inside. So I'm going to go ahead and put the cube root of 3. But why would I put, again, so much room between negative 3 and that radical? There you go. We still got to simplify the variables. Well, let's see here. Let's go for p. Its power is 2, but is 2 divisible by 3? It's too small. So I can't do anything to that squared. So that has to say p squared. If the power is smaller than your index, you can't do anything. Okay. But what about q to the 12th? What's 12 divided by 3? So that means I can pull out a q to the 4th. But there's no remainder, so there we go. In fact, I gave myself a little too much room here. So I'm going to go ahead and pull this back over. Just so we can tell, I'm going to make sure to put that radical in parentheses. But there you go. Negative 3 q to the 4th times the cube root of 3p squared. Okay. Are there any questions? Anybody not sure how I'm getting this? Okay. All right. Well, try 15. 15 is pretty nice to us. There's no number to break apart or simplify. It's just the variables. Okay, so don't say it out loud. Give everybody the opportunity. Try to simplify number 15 for me. Oh, you want me to check it? Okay. Perfect. Anybody else want me to check? Okay. Just one little detail. Remember that stuff. Oh, right here. Oh, okay, I was looking at this one. Okay. Perfect. 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 Okay. Detail. Remember, this is still. Other than that's perfect. 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 Good. 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 Perfect. Nice. Perfect. Nice. Okay. Let me go ahead and see what we got here. So I'm going to go ahead and make sure that we have the 4th root. Again, that's probably way bigger than I needed it to be. All right. So let's start with W. We take the power 4 divided by the index 4. Pretend those are 4s. So 4 divided by 4 is what? 1. So I'm able to bring out a W to the 1st. If you just put W, that's fine. Okay. Now for the V, we got to take the power of 17 divided by the 4. So 17 divided by 4 is, okay, 4, remainder 1. So the number of times 4 divides in, that's what I'm pulling out. So it would be V to the 4th. The remainder is what stays inside. And there we go. How many people got that right? Fantastic. Okay. Now, number 16, again, the same type of problem, but this one also has a number that we have to simplify. 48 is not a perfect 4th, so we got to find a number that will work here. We're looking for a perfect 4th. All right, so try this one. Okay. So because it's a fourth root, we're looking at these perfect fourths. What's the largest one? There we go. Okay, so use that. Go ahead and rewrite this for me. In fact, I'll go ahead and start it out for you. We know that the fourth root of 48, making that radical much longer than it needs to be. We can rewrite that as the fourth root of 16 times 3. 16 is the largest fourth root that will divide 48. And remember, you want to be careful because there are some numbers that could be a perfect square as well as a perfect cube or vice versa. So you want to be careful. Okay. Only thing off is this one. Perfect. Yes, there we go. We're at here 55. Okay. Think you got it? I hope we're a little off. Because remember, the 48, we can rewrite that as 16 times 3. So if you pull out the 2, and then I would look at your variables again. Perfect. Perfect. Oh, there's only one thing off. Everything's perfect except for that right there. There you go. Perfect. Perfect. Good, good. All right. Well, let's go ahead. Let me see if I can catch up with a lot of people in here. So, now remember, this is also one thing. See, 16, it's not only a perfect fourth, but it's also a perfect square. But it's really easy to go ahead and forget because you see 16, we're so accustomed to using it as a perfect square. But the fourth root of 16, that's a 2. Okay, so I'm going to have the fourth root of 3. See, that 3 would have to stay inside. So now let's simplify the variables. So I've got a power of 8 divided by 4. So that means I can pull out an m squared. And then what am I doing with n cubed? I'm just going to keep it as is. See, this power of 3 isn't divisible by 4. We're not going for a decimal on these. It has to be divisible by it. So I'm just going to leave that n cubed inside. And there you go. 2m squared, fourth root of 3n cubed. Okay, how are we doing? Okay, yeah. Oh, how we got 2? Because we're looking for a fourth root. Now, square root, if we had the square root of 16, well, that would be 4 because we're looking for 4 times 4, right? But when we're looking for the fourth root, we need some number to multiply by itself 4 times. So in this case, that would be 2, because 2 times 2 times 2 times 2, okay. Well, 2 times 2 will give me 4. That'll give me 4. And then when I multiply those, see, that gives me my original 16. So we definitely want to make sure you know what your index is, that tiny little number in the top left corner. Okay, that's our root. Okay. So let's go ahead and do a couple of these. This is the assignment that I gave you on Friday. Did anybody need a copy of it? Do you want to? There you go. There you go. That's it. got one in this row. Would you pass that, please? Anybody else need a copy? I got plenty. Go. Yes. You do it? Yes. Just like that. You got it? Okay. Anybody else? I got plenty copies. Plenty copies. Okay. So I would just say, you know, whatever one you want to take a look at, because it has all those different sections on here. Like if you take a look at, you know, 8, 9, and 10, and even some more, those don't have any variables. You're just simplifying the radicals, and you don't even get to variables until number 14. Okay. So is there any one in particular you want to try? Ava? Let's do 22. Okay. 22. Okay, so 22 says 5 times the fourth root of 112 c to the 24th and d to the 13th. Okay. Now, the one thing that's probably going to be a little bit of an issue for people is simplifying that 112. Let's do the easy part first. Okay. Let's go ahead and take care of the variables. So I'm still going to have this 5 on the outside. Okay. Now, we got a fourth root. So let's take a look at c. What's the power on c? Okay, 24. So I'm going to take that 24 and I'm going to divide it by what? 4. Well, that divides evenly. That tells me I'm able to pull out c to the what? C to the 6th. Okay, so that one's done. Now let's take a look at d. Okay, I've got d to the 13th. So this time 13 divided by 4. Now this one's not going to divide evenly, but 4 will go into 13 how many times? It'll be 3 with a remainder of 1. Now remember, the number of times it divides it, that's what I'm pulling out. So I'm going to pull out a d cubed. And what I've got left inside is going to be the 112 because we haven't touched that yet. And then we're going to have just d to the first. So all I've done so far is just simplify the variables. Everybody okay with that? Okay. So now it comes down to that 112. I'm looking for the perfect fourth that will evenly divide that. In fact, we just saw it a second ago. Yes. So if I'm trying to simplify the fourth root of 112, that could be the fourth root of 16 times 7. Now, just like on the previous example, we want to be careful. This is a fourth root, not a square. So what's the fourth root of 16? So that means I'm going to pull out a 2. I've already got the 5 there, c to the 6th, d cubed, times the fourth root of, I would have the 7, d to the first. So what's the only thing I still need to simplify? Yeah, the 2 that I pulled out, multiply it by that 5 there. So my final answer should be 10, c to the 6th, d cubed, times the fourth root of 7d. There we go. Ava, is that good? All right. Yes. What's up? Yeah, you got your badge? Okay. Is there any other problem you're like, I think we should work that together? $21? Let's do 21. Okay. I'll leave that up there for a second in case anybody's still copying. Negative 2 times the fourth root of 80, x to the 8th, y to the 9th, and then z. Okay. There we go. All right. Okay. So do you want to work this one together or try this one on your own? You want to do it together? Okay, let's do it together. So what would I do first? You want me to focus on the 80 or the variables? Let's focus on the 80. Okay, so I'm not worried about the variables right now. Let's say we have negative 2 times the fourth root of 80. So again, we're dealing with the fourth root. So we're looking at that third row of numbers that I provided you. I need a perfect fourth root that will evenly divide 80. 16, just like number 22. So this is going to be negative 2 times the fourth root of 16 times 5. Now, the fourth root of 16, we know that's 2. So if I pull that out times -2, -4 times the fourth root of 5. That takes care of that 80 right there. Okay. Now, here's what I'm going to do. I'm going to go ahead and put -4, but I'm going to put some room between it and the fourth root of 5. I can do better on that for you. Okay. All right. So we've gotten the 80 taken care of. Is everybody okay with that? Now we just got to deal with the variables. So the first power is 8. So what's 8 divided by 4? 2. So I'm pulling out an x squared. What y am I pulling out? I'm able to pull out a y squared. Is any y left inside? Just 1. And then the z cannot be pulled out. Why can't the z be pulled out? Because it's a power of 1. It's smaller than your index. So number 21, we should be getting -4 x squared y squared times the fourth root of 5yz. That's it. Yes. Yes. Oh, the fourth root of 16. Yes. So I can show you this middle step right here. So if we still worked it where the -2 was still on the outside, the fourth root of 16 times 5, we can go ahead and say that's 2 times the fourth root of 5. So see, because the -2 and this 2 were outside, we just went ahead and multiplied those. All right, how are we doing? Okay. Questions? Okay. Well, then here we go. Let me go ahead and shut this down for